Hi everyone, for this lesson I'll show you how to use the distance formula to find the distance between 2 points. Alright, so let's say we have these 2 points. Point A is located at 2, 4 and point B is located at 3, 7. So let's first label the points. This will be x1, y1. So x1 is 2 and y1 is 4. And for point B, it will be x2, y2. Right? So x2 is the 3 and the y2 is the 7. So if we go back to the distance formula, it's d equal to the square root of, in parentheses, x2 minus x1 squared plus, in parentheses, y2 minus y1 squared. So you have to make sure you pick the right coordinates. So for A, right, we're going with the x1 and the y1. Right, that's where we have to replace the values. And for B, for point B, the x2 is here and the y2 is here. Okay? Alright, so now we're ready to plug in the values. So D is going to equal the square root, in parentheses, another set of parentheses, and make sure you square it. And then now let's plug in the x1 and the y1. So x1 is 2, right, this right here. The y1 is 4, so that goes there. And then now we can plug in the x2 and y2. x2 is 3 and the y2 is 7, so that goes there. And now don't forget the minus sign. Okay. Alright, so this is going to give us d is equal to the square root of 3 minus 2, which is just 1, and we're going to have to square it. And then plus 7 minus 4, which is 3, and then we're going to square that. So now we're left with the square root of 1, because that's 1 squared, plus 3 squared, which is 9, and that's equal to the square root of 10. Okay, so the square root of 10 is approximately 3.16. Okay, so the distance between points A and B is approximately 3.16. Alright folks, the next concept we're going to look at in this video is perpendicular bisectors. So here's a diagram. We have line M. It cuts through segment EF. Notice that there are 2 markings here. The orange one, the little dash mark here and here, which indicates that line M cuts through EF at the midpoint. Okay? And also that line M is 90 degrees to segment EF. So whenever that's the case, we have a situation where line M is called the perpendicular bisector of segment EF. So if we were to introduce another point here and call it point P, then we can state that EP, the distance of EP, is equal to PF. In other words, P is the midpoint of segment EF. Alright, so that's all I have for you tonight. And we're done and we're happy.